Hey there, science fans. Today, we're diving into something that's literally everywhere around us and plays a crucial role in our daily lives. Can you guess what it is? That's right, it's the sun. Let's talk about the sun. This magnificent star at the center of our solar system is not just a source of light, but a powerhouse of energy that sustains life on Earth. It's a giant ball of hot gas, primarily composed of hydrogen and helium, and it's always shining. The sun's surface is a seething, boiling mass of energy with temperatures reaching up to 5,500 degrees Celsius. The sun gives us light and warmth, which are essential for life. Without the sun, our planet would be a frozen wasteland, incapable of supporting the diverse ecosystems we see today. But the sun does more than just keep us warm. It also gives us something amazing: solar energy. This energy can be harnessed and converted into electricity to power our homes, schools, and even our gadgets. Solar energy is energy from the sun's light. When sunlight hits solar panels, it excites electrons in the panels, creating an electric current. This process is known as the photovoltaic effect. It's a renewable resource, meaning it won't run out. Unlike fossil fuels, which are finite and polluting, solar energy is abundant and clean. We can use it to power our homes, cars, and so much more. Imagine a world where our energy needs are met by the sun. It's not just a dream, it's becoming a reality. Solar energy is clean and sustainable. It doesn't produce harmful emissions or contribute to climate change, making it a key player in our fight against global warming. It doesn't pollute the air like burning fossil fuels does. By reducing our reliance on coal, oil, and natural gas, we can significantly cut down on air pollution and greenhouse gas emissions. By using solar energy, we can help protect our planet. Every solar panel installed is a step towards a cleaner, greener future. So how do we capture all that energy from the sun? It involves a combination of technology and innovation, from photovoltaic cells to solar thermal systems. That's what we're going to explore next. We'll dive into the fascinating world of solar technology and discover how we can harness the sun's power more efficiently. Get ready for some solar-powered science. Stay tuned as we uncover the secrets of solar energy and its incredible potential to transform our world. Sunlight is made up of tiny particles called photons. These photons carry energy. Each photon is like a tiny packet of energy traveling through space. When these photons reach Earth, they bring with them the energy they have carried across millions of miles. This energy is what makes sunlight so powerful and essential for life on our planet. When sunlight hits something, those photons transfer their energy. This transfer of energy can cause various effects depending on the material the photons hit. For example, that when photons hit a surface, they can cause it to warm up. This is because the energy from the photons is absorbed by the material, increasing its temperature. Think about what happens when you sit in the sun. You feel warm, right? This warmth is a direct result of the photons transferring their energy to your skin. The more photons that hit your skin, the warmer you feel. This is why you can feel the sun's warmth even on a cool day. That's because the photons in sunlight are transferring their energy to your skin as heat. This process is a fundamental principle of how energy from the sun interacts with our environment. It's not just our skin that absorbs this energy. Everything the sunlight touches absorbs some of this energy, causing various effects. Solar panels use special materials that can capture the energy from photons. These materials are usually made of silicon, which has properties that make it ideal for absorbing sunlight and converting it into electricity. When photons hit the silicon in a solar panel, they knock electrons loose from their atoms, creating a flow of electricity. Instead of turning into heat, that energy gets converted into electricity. This electricity can then be used to power homes, businesses, and even entire cities. The ability to convert sunlight directly into electricity is a remarkable technological achievement that has the potential to provide a sustainable and renewable source of energy for the future. This process of converting light into electricity is called the photovoltaic effect. The term photovoltaic comes from the Greek word photo, meaning light, and voltaic, meaning electricity. This effect was first discovered in the 19th century and has since been developed into the highly efficient solar panels we use today. Photo means light, and voltaic refers to electricity. Together, they describe the process of converting light into electrical energy. This technology is at the heart of solar power and represents a significant step towards a more sustainable and environmentally friendly energy future. Solar panels are made up of many individual units called photovoltaic cells, or PV cells for short. Each PV cell is designed to capture sunlight and convert it into electricity. Think of a solar panel like a giant checkerboard. Each square on the checkerboard is a PV cell. The more PV cells a solar panel has, the more electricity it can generate. PV cells are made from special materials called semiconductors. We'll talk more about semiconductors in the next section. Semiconductors are materials that have unique electrical properties. They're not quite as conductive as metals like copper, but they're not insulators like rubber either. They're somewhere in between. Silicon is the most common semiconductor used in solar cells. It's abundant and relatively inexpensive. Plus, it's great at absorbing sunlight. To make silicon even better at its job, scientists add impurities to it. This process is called doping. Section 5. The magic of the p-n junction, where electrons flow. This section delves into the fascinating world of semiconductor physics, specifically focusing on how solar cells harness the power of the sun to generate electricity. Doping silicon creates two types of materials, p-type and n-type. Silicon, a fundamental element in solar cells, is carefully engineered through a process called doping. This process involves adding impurities to pure silicon to change its electrical properties. In p-type silicon, there are holes that can accept electrons. These holes are essentially the absence of electrons in the silicon lattice, creating positive charge carriers. In n-type silicon, there are extra electrons. These additional electrons act as negative charge carriers ready to move when an electric field is applied. When you join p-type and n-type silicon, you create something called a p-n junction. This junction forms the core of a solar cell, where the interaction between these two types of silicon generates electricity. This junction is where the magic happens. The p-n junction is crucial because it creates an electric field that separates charge carriers, setting the stage for electricity generation. At the p-n junction, electrons from the n-type silicon want to move to the holes in the p-type silicon. This movement is driven by the electric field at the junction, which pushes electrons towards the p-type side and holes towards the n-type side. This movement of electrons creates an electrical current. When sunlight hits the solar cell, it excites electrons, causing them to move across the p-n junction and generate a flow of electricity. This is the fundamental process that allows solar panels to convert sunlight into usable electrical energy, powering everything from small devices to entire homes. Section 6, from sunlight to electricity, the journey of a photon. Now imagine a photon from the sun hitting a PV cell. Here's what happens. First, the photon's energy knocks an electron loose in the n-type silicon. That loose electron is attracted to the holes in the p-type silicon. As the electron moves towards the holes, it creates an electrical current, and that's it. That's how solar energy is converted into electrical energy. Pretty neat, huh? Section 7, storing sunshine batteries for when the sun sets. What happens when the sun goes down? We need a way to store the electricity generated by solar panels so we can use it later. That's where batteries come in. Solar batteries store the excess electricity generated during the day. This stored energy can then be used at night or during cloudy periods. Batteries are like energy piggy banks. They allow us to save up sunshine and use it whenever we need it. Section 8. Using solar energy powering our world. Solar energy can power so many things. We can use it to light our homes and businesses, power our appliances and electronics, charge our electric cars, heat our water, and as solar technology continues to improve, the possibilities are endless. Section 9. Keep learning. Solar energy is the future. We've learned a lot about solar energy today. We've explored how photons in sunlight are converted into electricity by PV cells. We've also discussed the importance of semiconductors, p-n junctions, and energy storage. But this is just the beginning. There's so much more to discover about the exciting world of solar energy. Keep asking questions, keep exploring, and keep learning. Remember, the future is bright and it's powered by the sun.